And here in Nagpur, energy, and third is pin code 440022. The direction. Here I'm finding the shortest path here. Is how I move. And assuming that in this route my bus is there, for example, my bus is in this position, I will get the distance. It means how much it has to travel, how much distance it travels. Again, and the idea behind this is, for example, my family is traveling, and during some on the way I lost the communication with them. So I will go to the click here. I can get the exact position of the bus. And the three fields we have provided here. If I click on this link on this bus, if my bus is here present, that's what we explained here. It will show three colors: red, blue, orange, and green. Green means it's moving properly. Orange is it's lacking. Means it's before time. Before time, and green red says that it's late by time or it's some inconvenience in the my bus. If you drill down, we are getting the shortest path what here what Google provides. Using Google. So we are setting a static area here. For example, I'm using orange travels. So I'm having 10 buses which are moving towards Bangalore from Hyderabad. And they are moving in the time period of half an hour each. So if I click here, SNR for example, I will get 5 kilometers of area here, and you can see that how much distance they have traveled. It's again a static means. And live traffic. This is simple we implemented shortcut live traffic streaming. This is helpful that if I'm moving towards from Amirpet, from High-Tech City to Amirpet, during the office hours the traffic is more. So we can suggest to the upcoming station that this bus will take extra 5 to 10 minutes to reach this station.
So the image showed us.
Yeah. What is that I hear? Can you turn that off? I hear something. Do you guys slightly? Where's that volume coming from? Here? Okay, good.
So the number is eavesdropping. So, quick question: the image you showed moving, right? I'm assuming that you give the data from where these guys provided you the data, right? And then, were you simulating it, or how did you do it? I mean, what you showed so far is concepts, right? One thing that is close enough was you showed the image moving on the screen, right? Is it a?
It's not live.
Is it you're simulating that? How did you do it?
The data is what you are provided from the.
Yeah.
But the image we have put using Ajax control on that. So to add more cream to the.
So how are you moving that? Where is the data? Where do you get the data? Move the
image on the image that we are moving.
Yeah. So this one.
Yeah, it's calling the data every 1 second, 2 seconds to get the actual location.
Yes,
of the
yes.
bus.
For
we are assuming the location of the bus.
Simulation.
And here what we will implement, that's why the bus is moving. We are implementing.
Okay.
We just apply the random function for this.
GPS sends some data, the location of the buses, then the actual movement.
So it's a simulation. It's not a live.
Not live.
Or 5 minutes
Not
delay,
live.
10 minutes delay. It's not. Okay.
Okay, so this data, where you take this data from? Which sensor?
Deep. Smartest to add more cream to that. New data.
Is it from the consortium itself?
Yes, consortium.
This is a data. This data.
So they're basically posting the data for every 5 minutes.
We provide the location, bus location, and the latitude on
Bus stop.
bus stop.
We got that data and stored in the database.
Yes.
So we just sort of the actual process or the data getting.
So everyone has their own kind of sensors to data. So we are posting some of the temperatures, whether since from different some people are posting the parking, some of them are posting the buses, something else. Tourists to the bus one, the transportation one, so we're worried like they were able to communicate they come over, they try that stuff. So they're using the data, they're using the data.
Is this a real time kind of thing or is there a lag in it?
Yeah, it's actually, I think like, yeah, there's a lot. Basically, they post for every 5 minutes, how they post. Some of them are real.
Second.
So for the app, which one is actually getting the IoT data and live and you're showing something on that?
Here, the bus movement we are getting. Actually, the data is it's bus stop names only.
Okay.
Bus
It's
stop
fixed.
in the,
Bus moving we are not.
You don't have the
Yes.
yes.
Only the bus stops you
we,
know.
bus
we
stop.
assume the bus loop.
We assume the bus location. It's
But
moving from this time to this time. For example, I'm moving from Madam Tussauds to Yorkshire. So it takes, for example, 30 minutes. If it's morning hours, then I'll add a function there that I will in morning hours and rush times I will decrease the speed by 10 minutes for the bus. Like that we assume. And what we are next our aim is here you can observe the trail radar. It's showing the direction in which my railway is moving. If we click on any one,
But this is not what we get, right?
It's not what it is.
No. Let me ask you something. Especially today, where do you spend your time? I mean, you spend some time basically giving the data, writing a server program to simulate, right? That's the
Yes.
point.
Yes.
Core of it.
we are getting here pop-up that this map, for example, assuming this map bus, it will show how much time it is, expected time, arrival time, and complete the path. Yeah.
But this is what you want to do. You haven't
Yes,
done that.
yes. Lack of time.
Okay, got it.
You mentioned the capacity of the bus. Is that something which is set?
What we are planning, 3 sensors would be there. Means first and 3 means first is in incremental order, third in decremental. If we pass the 3 sensors, it is the bus is inside. If it's in decremental order, the bus is moving out from the bus.
The capacity of the bus itself is a parameter which is already
Fixed.
Which is set.
It's fixed. For example, this my bus is capacity 80. The capacity is fixed for that bus 80. If 81 candidate comes, then it will automatically send one signal to the bus stop nearby that we are suggesting to arrange a new bus.
Does the data have that thing, that value that this bus?
Is there a sensor that is telling you right now?
That is the capacity of the bus?
No, right now we are assuming that.
We assume.
But within the column, is there a thing that this bus is?
Yeah, assume.
And I think like they also had an idea of having in how many people are getting to the bus. Yeah, I think that's good.
Our next agenda for this is we are planning to implement using RFID, GPS and all. We are
So how are you going to use RFID?
We are on the track. I don't know the title. Expert who mentored us yesterday, he gave us a good idea to go with the RFID. So we drilled down yesterday only the what is exactly the RFID, how it should work. Okay, so we
Which was the most challenging part of this? When you were
Taking data from server. What was the challenge?
We are taking JSON data and we are converting it to XML and storing in data. That was another issue.
Well, so so just and stuff. Right?
Actually, we don't know how to convert, we store the JSON data to data. So we converted that JSON data into XML and we stored it.
So SQL Server can handle XML data.
yes.
We are right now comfortable with XML.
Simple that man. Oh, everybody is always just on.
Today the need is JSON.
Perfect, thank you.
Thank you.
Thank you, sir.
Thank you.
Thanks.
Just is a lot.
Is there a function? Function. This one is function. This function. Good. Function X. Yes, ma'am. Sure.
Okay, since I do it, I probably could just go with the experience of knowledge. You press function.
Yeah.
Yeah, so. Should just switch from the laptop. So.
Yeah.
You want an internet? You want an internet right now?
Yeah, she connected. They're asking everyone to connect. Yeah. Standing.
Hi sir, I am Renuka. I am going to deal with the temperature monitoring system. Actually, we are 4 members. Unfortunately, they were left. I am only one who is
Okay, so.
So, Internet of Things. Let me give you some live example. Like when I am going to my uncle's house, let I clap that light will on, fan will rotate. That is so much interesting things. So I want to learn something. I was learning something. Thank you so much for giving this opportunity. And coming to my project, where I'm dealing with temperature monitoring system. It is whole about server temperature, server room. It is dealing with the what is the temperature of the server and how it is. I'm connected with the sensor and getting that data, and I was converting into a user-defined whatever it is. That is a chart that we are into. That I was converting into chart. After that, if that temperature is going in, that may be a problem for the server. So I need to send the SMS to the particular person. So I was sending that message to particular person. So if temperature is going, that is
You have something to show us?
This
You
was
can connect to the project.
There's some problem with the partner.
Okay. Okay. Sorry.
this is my template. And after that, if I want, I'm getting the paper.
Those are all individual sensors?
Yes, it means some sensor. Whatever the sensor giving the output, I was converted and storing into a database. After that, that database in the chart. If the temperature for the limit is exceed, so the water sensor is increased. I'm using this developed this into computer. So I'm using a replacement using a separate. It is an online network that we will store and we can register. They are giving the relation code and all. After giving the credentials, it is asking for your login and your that person and I want to send that to get that type of message it will go to so we can
So you think there's a variation outside of the range that person is it working out or it's it was beyond
I'm showing the threshold value right now.
yeah. So who gets so if you did it that's wrong now, who gets the message? Okay.
Yeah, we'll give you just
Yeah.
Somebody's number and you set the threshold low.
just put your yeah. Put your number.
To see how
Is the data being pulled from the server? Is that real time?
So we got some data in the CCS server then with the so there's a temperature variance. So using the temperature variance. You can just give it a
99908.
That's what happened, right? It's live.
Who's watching?
All the participants also. That's what the whole rule has started going there.
Okay. I better behave. Well, the rest of the team has left their night. Yeah.
And she was the one there all night. She was working all night.
Oh, really?
I got a message. Yes.
So we need to connect the, the map, right? So they are getting from somewhere, right? And then when it reaches the threshold, does it automatically send to or it's not connected yet?
So now it's not sending out anymore.
Yeah, but it's easy to do, right? It's not that.
And the message should have what the variations.
And also the location.
Pretty good.
Hey, good job. They tell us that you were the only one working on this all night, so.
She got the
All
output.
night, yeah, okay. That's good.
Crashed them, man.
Yeah. Good job. Thank you.
So are you?
others provide microsoftware services. It is means under the knowledge technology.
Are you open?
They are giving too much money. After that, they will raise
She's looking for an opportunity now.
You use this. You built something in less than 48 hours, so that's a good thing.
Who's the next team? Okay. Yeah. Hari, next team.
Thank you, sir.
Ready?
No, what is also excellent. There's some something like this. This is an idea like this. Okay. We provide the data. We provide the data. Some of the people run the data. Some of the users.
Stop.
Good afternoon, sir. So we are just presenting on the smart metering. Like day by day, every technology changes like that. We have a human interaction during the meter reading process. For that reason, we are using the smart metering. That means one sensor is installed inside the meter, and that will be senses from the whatever the meter reading and the amount of units also. And it will be fetched from one meter, and it will be sent to the master sensor which is present and which is holding more than 10 to 20 sensors at a time. From that sensor, it will be fetch the data and it will be focused towards the server. And in the earlier days, the meter reading, meter file generation is done through the pen and paper, but by fetching the servers, by getting the sensors data to the server will generate a PDF file of having the electric bill as well as send a message to the respective registered user who are present in the electric board. This is going to just that is the smart metering. And due to the little bit time, we are just thinking more than the technology. Some transactions will be added to this after getting the successful data from the users. Some amount, the respective amount will be deducted from his account. As well as nowadays in summer, most of the power cut is going on in our cities, and many people wants to know the reasons behind why the power cut is going on. For that reason, we want to add some technology in that, but due to the lack of time, we are not interested. And also, the people also get the data by sending the SMS from his mobile, and the server will send the data while the power cut is going on. And even if the weekly schedules, the power cut is changing. The power cut probably changes. That means 11 to 12 for the first week. Then it will be changed from 1 to 2. Then that information is also given to the users prior to run the process.
You have a demo to show?
So this is the first method. If the new user wants to add, then from that user we have to JSON data, and from the first user, then it will be, if someone having not the registered, then he will first register, and after registering the data will be stored in the database. Then after that successful registration is done, the same data will be transferred to the, that means stored in the JSON format. And from the JSON format, when the server continue to be that is amounts or the units will be formed, that time the units will be sent to the master server, and from the master server it will be sent to the respective emails and as well as the SMS. And these are the JSON data we are taking. The unique ID and the unique ID present in the unique ID that is present in the master sensor, that will be same as in the the PDF file will be generated, and that will be matched. But at the end of the month, some timer will be fixed at the end of the month, up to 25 or 27. It will be sent the PDF files where the users make it.
This is obviously a HTML files, right? They're not really working.
It is a server. So when the new user is added, that means
Is it really working now?
yes.
Because I see that it's an HTML file. So. Can I submit it and then see what it's generating? And the data is you're using your own data.
Yes.
So assuming that if there is a meter and the smart meter which actually pushes the data, sorry, assuming it created it.
And
They created that in the database.
the same thing. Maybe.
Like,
Actually, it is mostly working, but during the launch there are some just testing, just little bit change for that reason.
if you change the mail ID,
It's mostly working.
Well, this is the green output.
that is the Java file that is running in our machine, sir. Right? That is the Java file that is running in server machine. It generates, it takes the email ID from already registered user, registered with email ID with our database, right? We will take the email IDs from our database. From each email ID, this program takes one by one. Then it generates the PDF and that sends the PDF and attached to the email ID and sends to the electricity bill. It generates the electricity every one by one and stores in on the drive, and as well as it sends to the send to the every mail ID.
Okay, that is just setting the GSM modem. Okay.
From this each individual's data will be get to the mail, and as well as one message will be forwarded from this number.
Is it really working?
Yes,
You
yes.
tested the GSM?
Yes, yes.
Critical GSM, your phone.
And just okay.
Well, you can connect the phone, and the phone can actually just modify. That's what they do.
Actually, it's TSK, what key messaging service is not available for that. We take the help of the dongles, and through the dongles we are sending the messages. That means the message will be passed from our SIM card also, having the messages. From there, we will be sending the.
May I take the
If
may I take the fixed data?
We understand the concept, but if you read the data coming from, or we have simulated data, then reset, whatever you're trying to do, it will work the whole thing.
yes, sir, yes, sir, definitely. To get the time, we will also.
Thank you.
Thank you.
Hi, Hackathon. It's, our team name is uh, Geek Band and our
Sorry?
Geek Band.
Geek Band.
Yes, sir. And we are developed an application with name Traffic Plus Plus and Traffic Minus Minus and Joy Plus Plus. It shows the minimum distance from source to destination.
Yeah, in cities like Hyderabad, traffic has become the major problem. Even people to go to the offices or from offices to the homes, it takes much time. So we wanted to solve this problem in these 2 days. So we tried to build our application using Python, and the database is MySQL. And the concept we have used is when I will explain you to this that. Let us suppose a person wants to go from G to D here. Now he has the alternatives G to B, B to C, and 2 paths here, and from here and again 2 paths. So in these junctions, here we have junctions G, C, and D. Let us take the junctions G and C. Now, whenever the user comes to the G, he wants to know whether he could reach faster through this way or this way. So our application displays the way which is the effective one and through which he can reach his destination in lesser time. So let us suppose here we consider these are the costs, or what we call as distances to the destinations, and we calculate the density of the traffic based on a number of, let us consider a criteria. Let us take the width of the road. Only few vehicles can be emitted in that width. So we calculate the density by measuring the number of vehicles by the road capacity. So that would be the density, and we multiply that density with this distance. So that result, which result will be lesser, takes less time. The product of
So you got the density of the traffic. You have the cameras.
Yeah, 2 cameras we capture the number of vehicles by the width of the capacity of the.
So use the pattern.
We can use pattern recognition, number of inflowing vehicles, by using the security cameras around the junctions, number of vehicles coming in and number of vehicles leaving the road at a particular junction, and number of vehicles will be in the traffic, right?
I get it, right? So you're saying you're going to use pattern recognition to
Yes.
understand number of vehicles.
We haven't used any kind of sensors, but we have used simulated data.
Then for the distance.
Yes, got the distance, number of vehicles that the road supports will be in the denominator, and the current number of vehicles will be in the numerator. So it will be less than 1 in most of the cases. If road capacity, we can't exceed the road capacity, right?
Simply the intensity, we can call it as intensity of the traffic.
So more the density, more the time. Yes, and more the distance, more the time. So we are taking a compound product, density into distance.
Let us suppose here it is 8 and 9, 17, 12 and 8, 20. But let us suppose though the distance is more here, if the traffic density is less, he can reach faster through this. So we will suggest the route here to take this route. And coming to technologies,
we have first hard coded these graph data, the adjacent vertices. For example, G is connected. Okay, G is connected to A and B. So G will be in one column. Every node will be in one column, and its adjacent neighbors will be in other column. So we have inserted that way in the database, and we have used MySQL. first we hard coded everything, like from G, B and A are there. So we have taken the distances also, and we have kept this cost and densities in another table. Connecting G and B, the cost is this much and the distance is this much. So we will show you once.
You are getting the map data, by chance, the maps where from point A to point B, get the distance.
We found it difficult to get that data.
See, first we have hard coded everything. In this, here we have hard coded everything. A is connected to G and C. These are the adjacent addresses. So then, after hard coding everything, we have put the data into the database and fetch the data. This basically uses a BFS implementation, breadth first search. So in breadth first search, when we find a path, we will stop usually. But here, till we find all the possible paths, we don't stop. We will be continuing searching, exhaustive search. So this is how it happens. Once you move on. See, it is a queue implementation for breadth first search. See, suppose I want to do breadth first search on the graph. Graph is what I have declared on the top from G to D. So this is the path queue. This will be an empty queue in the first case. So I will be getting the all possible paths. So after that, I will be calculating the sum. For every possible path, we will be calculating the sum. So minimum distance into product value is taken. Distance into the cost. So minimum of that is displayed. Okay. So we can also have intermittent. Can you once take the picture? See, here we can have a display board showing that users can take this path. After a certain amount of time, when the density increases and the other side is capable of receiving the traffic, then you will be diverting it over here. This can be done by the government at the junctions, as well as can be sent to the individuals through their mobile. So here also we will be having one potential display LED.
The problem is if we make it a mobile app or all the passengers at that particular junction may not use it. So if we could display that results at that particular junction, everyone can.
I understand the algorithm you try to code, but how are you going to apply to the real world, right? Okay, what you did, because of time, you have already did, right? So how are you going to apply that to the real world is something I'm trying to.
We are considering the density of the traffic, right, sir? The cameras at the traffic junctions will be capturing the number of objects. So, if for every, for example, we consider a time span of 1 minute. For every 1 minute, it will be updating the database with the number of objects in the particular row. So, we will be calculating the compound product. So, we will be estimating the optimal path at that time.
At the real time, we will be dynamically calculating the possible.
After diverting traffic to a particular route, once again, in that particular route, traffic will be increased.
Continuous
in the other
sensing of data will be there.
So in the other part, traffic will be decreased. Once again, we will be scanning the data and we will be again updating it with the new data, new routes to go to.
So suppose, for example, you stuck up in the traffic in one way, and in the other way it takes 3 more kilometers, and by the compensation of that fuel, he can reach the path faster, the destination faster.
Here, fuel saving is also.
See, this is the result you can see. For all there are 4 possible paths, right? So these are the possible paths, and this is the measure, and we have identified the best possible one as 4th one.
This measure is the product of density and distance. So out of these, the minimum will be the best suggested path.
In the very near
Yes.
future,
Yes.
we have driverless cars, right? Each car gets its own message.
Yes, once.
So the city need not bother, this program. Just got to tell this destination via this destination. Thank you. Then see.
Usually, we will be having a signboard displaying this many kilometers to reach high-tech city. But however, the people choosing that path will be stuck in the traffic. But instead, if we are going to display this much time,
12 minutes per high-tech city, it will be better.
People will be choosing the time in path in which they can travel in less time.
rather than the distance, they will be concentrating on time, right? So instead of showing 6.5 kilometers, we can display 12 minutes
12
to reach.
minutes, 20 minutes to reach.
Yeah, I think the concept is good, right? If you have time, probably you could have gotten.
Yes, we have checked for the real world data also. We can use simple CV in Python. Using the cameras, we will be calculating by training data, we will be seeing the number of vehicles in
Does government give you access to that data?
Right now they are they are capturing the data. Yes, we can see the security cams over there.
No, that I know, but can this be applied in the real world?
If the government take the government permits,
There's certain things right now. The cameras they have is pure security. So what they're talking about is you have to calculate the depth and stuff like that. People
yes.
Yeah, now we have automatic traffic system. So if there are less number of vehicles, the signal
will be automatically computed from one lane.
The same type of camera can be used.
How can you use the same?
In LB Nagar, it is happening, sir.
Yes. Sir.
So number of vehicles are waiting in a particular lane. So if there are fewer vehicles in the other lanes, then the signal will stop the lesser vehicles.
Previously it was about 1 minute per each.
Yes.
Previously it was about 1 hour.
Yes.
Actually, it also integrates downstream. So if there is, high traffic, it ensures that the next signal is also.
Yes,
it will be
The sensors on the road. There are two things, right?
It is through cameras.
Sensors on the road is what?
Cameras.
No, actually, they have sensors on the road.
Not the camera.
The camera is related to the
I
camera.
know
It's very
you got to have the depth of doing communication and stuff like that.
I think it's done locally, right? Smart signaling. That is the emergent ways. Just bringing that. I think even an output going to an FM radio format or something would be quite interesting.
Yes, many people
yeah, you almost get continuous feed on the traffic.
Think of what he said, right?
Yeah,
Rather than
it's
looking at the camera, you should use the sensors on the road.
Yes.
Yes. Now the other problem with the cameras will be like it will feel like one big vehicle on it.
Yes, camera doesn't recognize the depth. Most of the cameras doesn't recognize.
Whatever that vehicle is.
Even combined to the
Yeah.
And coming to our future enhancement projects, right now we have not associated the application with the Google Maps. In future, we will be considering the areas and the traffic, and we will build a customized Google Maps showing the density of the traffic at a particular place. So if when someone wants to go outside, they will be choosing whether should I go out right now or should I choose to go after an hour.
But Google Maps does that now.
Only shortest path, only one way they will be showing how much
It
time.
shows only the densest traffic path.
Traffic they are providing,
No.
the density they are providing, high, low, medium. That's it. They are not providing an alternate path using which he can move.
No, they do that. So Google, let's say, it gives you options on how many routes you can take. Let's say if we want to go from here to
Recent update, after recent update, they have removed it.
They have removed
Only we can, yes, we can change the tolls.
You don't get options on how you want to.
Yes.
So they just give you one. That's
Only
Yes.
single unit.
Yes,
one
single
real
toll.
minute. Okay, I didn't know that. Okay.
There is a
That's bizarre. Yes. Yeah. Usually it gives you 3 or 4
Yes,
options.
previously it was giving, now it is
we can track the
Maybe
route
that would be a
to
paid option.
in the older version of Maps, we have option to track the route to another place, so we can travel to.
Right.
All of you to them?
Yes.
But the sensor, in the US, the sensor usage is a big thing in controlling traffic flow, right? You would want that major arteries of cities, you want the traffic to flow through and not stop it. Alternate light shouldn't be green or alternate light shouldn't be red, or you see what I mean, right? And I don't know how well that's managed in India.
In India, we can allow only 2 lanes. For example, there is a 4-way junction. It is mostly seen once the vehicles are going this way, and he can go in that way. Only 1 lane he will be allowing to go in 2 ways. The other 3 will be waiting.
You check post the manual police
Right.
That's the best option.
Thank you.
Thank you.
Thank you, sir.
Thank you.
Reduce resolution. Oh, chairman. So we're using Ubuntu for coding as well?
Yeah.
Development as well. That's it.
Good evening. Our project is online. Our project is online pollution monitoring system. So we have used the MongoDB and PHP to develop this application. So imagine a network of sensors. So we'll be having, for example, 1,000 sensors in Madhapur itself, and 10,000 sensors in Hyderabad, overall Hyderabad. Okay, and the frequency of data we are getting is, for example, for the accurate data, for every half an hour we'll be getting data from sensors, and we'll be aggregating it. For a particular area, we'll be having, we'll be aggregating all the sensors in the particular latitude and longitude, and we'll be showing the data. You can show on sensor. So we have taken this 15 dummy data. So actually the original data from UK, we have just changed the latitude and longitudes. So if you want to see this Kokatpalli areas, so we'll be showing this last 24 hours. So if you are seeing now, so we'll be calculating minus 24 hours from now, and we'll be aggregating all the data from previous 24 hours, and we'll be showing it here. For example, nitrogen oxide is 64.57, and PM2.5 is 7.2305, hydrogen sulfide is 15.615, and sulfur dioxide is 3.70.
Is it safe to go there?
And like this, for example, what is the scope of this project? Like you can say, Andhra Pradesh Pollution Control Board is also using this kind of project already. So what's the big deal in doing another thing? So why to reinvent the wheel? So what they are doing is they're displaying a static data of particular day and no transparency. For example, Andhra Pradesh APPCB mandates that 115 milligrams per meter cube is highest for SPM, suspended particulate matter. But many industries violate regularly, and they even evaluate. Emulates 300.
You're saying that today,
Yeah.
PCB,
Yeah.
they're publishing this data.
Yeah.
And on different roads.
Yeah.
We have discussed it. That we've seen, they haven't done this.
So there is no platform called to gather the data for previous months or previous days, or make someone responsible for over pollution, something. Because when you have a data, you can take some data-driven decisions. See, for example, you have ozone layer is depletion, so you can take measures like green plantation and green initiatives, and you can do. Community can do a lot of things if there is an efficient data. So our system looks at network of sensors, not a particular sensor. Network of sensors. For example, as I said before, 10,000 sensors in a city. So we'll be getting very, very accurate data that can be compared with other cities or other towns and other areas in the state or India or anywhere.
Let me stop there.
Yeah.
How are you going to get the data?
So we'll be installing sensors,
Okay.
and sensors will be sending data to our systems.
Okay, you're assuming that you can get that.
Yeah.
Okay.
And So you can have any number of.
How many sensors do you think the government has now deployed to do this?
They have deployed
Here
for
in Hyderabad.
in Hyderabad. I don't think in public areas they have deployed many sensors, but in every industry, stack industries especially, which are producing stack gases like thermal power stations and these industries, they have mandatory rule to have a sensor. I mean, to have a sensor and to send their data every day and every hour actually. So more data we'll get and more data-driven decisions we can take. So our system capable of collecting all that data. So I don't say that this is very big scope project and big data is involved in this, but actually I do. I mean, we have did this on MongoDB, which is well known for big data. So I'm saying that it can handle big data also. So if you increase frequency, say let us say for every 10 minutes you are sending data. I mean your sensors are sending data, so you can get more accurate data also. And we'll be having some, from yesterday we have been an exciting part. From many days, for our other project, we are trying to do this geo within spheres. In MongoDB has a special queries. If you have a latitude and longitude, you have some 10 lakhs or 1 crore of documents. So document store. So with this geo within geo near queries, you can extract the particular IDs which are near to your latitude and longitude. So we are at in this point, you'll be having some radians 0.012 around 20 miles. 0.012 radians is. So we'll be giving that latitude, longitude, and radian. So we'll be getting all the sensors data at a time.
Another MongoDB uses MapReduce, right? Isn't it?
Yeah, MongoDB uses MapReduce. Actually, we also did MapReduce for this one of these things.
Which is okay, but I was trying to understand, right? Whether you're focusing on once you get the data, using the big data concepts to add value. That's one piece, right?
Yeah.
Is that, or you're implementing a system to get the data, right? To get the data itself, right? Several sets of install and get the data. It's not a kind of power, this and that, all kind of stuff is there, right? What is the value proposition of it?
So actually, when we started here, started hacking here, organizers has said that we'll be providing data. So you have to build an application for the data. So the entire concept revolves here is data applications, not to how to capture data. So there are, I don't say it's an easy task.
It's a data part.
Yeah.
Adding value on the big data.
Yeah.
Right? Using the big data concept, you're trying to say. Yeah. This is what you're gonna tell the people. Yeah. Right. Okay. Right.
And yeah, you can have area data, and we are planning to do this on. First we have started with only air quality sensors, like this. I have shown this CO, carbon monoxide, SO2, and everything. So later, this architecture that API is provided by organizers has shown us these can be implemented with temperature, water quality, and noise also. So the whatever functions we have written here, that will be applicable for these sensors. These data also. So moreover, they are related to nature, and we can implement that also here.
So currently, you did not use our data, right? You did not use.
No, actually, we have used your data, but we have just changed latitude and longitude for easy understanding and.
So you just change latitude and longitude.
Just latitude.
So the position data is not from IoT.
No, it's from IoT. It's from IoT. But we have changed just latitude and longitude.
Pollution data is from London.
Yeah, no, we have an air quality index. So that's the data they got here. So you get comfortable supporting coordinates. Yeah, change those locations.
Some AQ sensors and sensotonic something.
Right. So that's the other thing, right? You can do a lot of comparative analysis.
Yeah.
You have London data, Vijayawada data,
Yeah.
Hyderabad,
Yeah. Actually, we have already written that functions. When I can show some, I want to show some graphs also. We have figured out some graphs, but you can show this area data. For example, this area data belongs to entire Hyderabad. Entire Hyderabad. We have run some programs and aggregated the all, what to say, grouped the things, particular type of sensor. So H2S values, PM10 values, this one, and everyone is an average values.
Okay, what is the graph, real-time graph you're doing? It's a simulation. You just running it.
Yeah, actually.
Okay.
Yeah, we have excellent JavaScript libraries out there. If you have a data, and we can do wonders in visualization. Yeah. I can show you some database also.
Yeah.
See, this is the data provided by IoT. So exact data, same. I mean, the format also same thing. What I'm saying is name ozone. Long name is ozone. You can say that, for example, name is temperature. What we deal with is name and value only. I mean, the other things may be required at future time. I mean, the last update also. Last update is the time when we get the data from the sensor. Okay. So ozone is on 23rd 3/2014. We got data. So for example, we can have noise data, temperature data, water quality. So this structure helps us. And why we use MongoDB is, schemaless and having helpful for other. I mean,
where's the PHP code?
Yeah, PHP code.
Quickly.
This one. Functions. You open functions. So this is the functional. Okay. So actually these functions, for example, pollutant head sensor. So this function aggregates the data at a particular sensor, and particular pollutant param string to pass into the function is pollutant and sensor ID. So we'll be getting sensor ID from latitude and longitude, for example. So we'll be getting from another function also, that latitude and longitude sensor IDs. So we'll be passing sensor ID and pollutant.
So this is the code you did.
Yeah. And lot of code. We have.
Alright. Got it.
So upon clicking on these things, for example, you click on this. For example, this is at Secunderabad railway station. You click on this. We'll be having particular station records. We are not having large data. That's why we haven't produced any graphs here. Okay. For example, we have deployed. We have inserted 20 documents here for 20 stations. 20 stations. Each station got four documents. So it's a lot of. We have inserted manually 80 documents here. So it becomes impossible for us to do in one day a lot of data here and produce some graphs. But actually, our idea is if you go to the Secunderabad railway station, you will be having historical data. You can have a range query, data range query, select the data range, and you will be getting visualizations.
Even also, we can get the particular time at the same location. Like in Madhapur, it will be something pollution very less at the time of 2 o'clock in the afternoon. But it will be very high in the time of 6 o'clock in the evening because all the offices were released at a time. All the people will be on the road. So the pollution will be very high. We also plan to get some system like at a particular time, if at a signal, we should track the system for every 3 minutes so that whenever the signal gets red, so the vehicle stops. So how much carbon monoxide is releasing at that particular location and how can we control that? We also going on with that data along with this. Any more queries, please?
Why PHP?
I'm a PHP developer. Okay. I do a lot of projects in PHP.
Thank you.
Thank you. Thank you.
Good evening, sir. First of all, I would like to introduce my team members. Myself, Avilash, Keshav, Shashikant. Good evening. Sujit. Okay. We have prepared one app that is a safe and secure your office. First of all, I would like to tell you one scenario. Assume that this app is only applicable for any organization or any office. Assume that in the night every office is closed.